Hey there, and welcome to Module 1, Lesson 2. I'm Miss Garber. Today we are working with proportional relationships. No need for extra materials today, so let's jump right in. Let's start with example 1. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. Determine if the cost is proportional to the weight. I'm wondering, does everyone in Isabel's family pay the same cost per ounce for the frozen yogurt? How could we find out? You might have been thinking that since we want to compare cost per ounce, we can use the unit rate to determine if each member is paying the same amount. When we divide the cost by its corresponding weight, we see that we have the same unit price of 40 hundredths for each dish. How does this help us find the total cost? You might have said this will allow us to use a multiplicative comparison to show that when we multiply the number of ounces by 40 hundredths, we can find the total cost. Because this is true, we can fill in the sentence in our materials. The cost is proportional to the weight. Now, Isabel's brother seems to be pretty hungry and is taking an extra long time filling his frozen yogurt dish. When he puts it on the scale, it weighs 15 ounces. If everyone pays the same rate in this store, how much will his dish cost? We know that if we multiply the weight by 40 hundredths, we will find the total cost. Her brother's 15 ounces of frozen yogurt will cost $6. Let's think. If Isabel's sister is not hungry and does not want any frozen yogurt, what would you expect her to pay for 0 ounces of frozen yogurt? You might have said $0. We can show this is true by multiplying this constant value of 40 hundredths by 0 ounces to get the cost of $0. Since we have a proportional relationship, we can always multiply the number of ounces, x, by the constant that represents cost per ounce to get the total cost, y. The equation that we could use to represent this situation is y equals 40 hundredths times x. Let's move to example 2. In the back of a recipe book, a diagram provides easy conversions to use while cooking. This diagram is telling us the number of ounces in a given number of cups. Let's think. Is the number of ounces proportional to the number of cups? How do we know?
When we think back to our last example, we might recall that if there is a number that works in every case, there is a proportional relationship. Let's take a moment to review the pairs of numbers in the table. 1/2 and 4, 1 and 8, 1 and 1/2 and 12, and 2 and 16. Are you noticing that the second number is always 8 times the first?
With this information, take a moment to complete the sentence in your materials. The ounces is proportional to the cups. If we wanted to write an equation to represent this proportional relationship, we need to define our variables. Let's have x represent the number of cups and y represent the number of ounces. Take a moment to see if you can write the equation that would allow us to find the number of ounces, y, for any number of cups, x. Does your equation look like this? Y equals 8x. To check our equation, we could substitute a value of x into our equation and see if we get the corresponding value of y. Take a moment to test our equation with a couple of our x values. Did we write it correct? Pause the video now to test the equation. During our time apart, I hope you were able to say, yes, our equation was correct. Because when I substituted an x value into the equation, I did get the corresponding value of y. Before we begin example 3, I'm wondering, have you or a friend ever worked to earn money? Maybe you were saving up to buy something special by mowing yards, babysitting, or helping around the house? We're going to take a look at how Alex spent his summer working towards buying himself something special. Read how Alex spent his summer by pausing the video now. Press play when you are finished reading. Now that we have read about Alex's plans for the summer and how he is hopeful to have earned enough money to be able to buy a new gaming system, let's work together to answer Alex's question. Alex probably decided to use a table to easily see how his earnings would grow over time and whether he would have enough money by the end of the summer for his new gaming system. But I'm curious, where did the two given data points come from? Maybe you looked back at Alex's story and saw that he told us he earned $112 after working 4 weeks. But what about the data point representing 1 week and $28? Could these points be related to the unit rate? If we divide $112 by 4 weeks, we see his rate is $28 for every 1 week. What other pair could we fill in fairly easily? Maybe you were thinking at 0 weeks, he has earned $0. If he makes the same amount of money each week, how could we find out his earnings for the entire summer? You might have been thinking we could multiply each number of weeks by 28 to get the corresponding total earnings. We know this is true since the rate will be the same for each week Alex works. Looking back at the question, I'm wondering, will Alex have earned enough money by week 8 to buy his gaming system? Take a few minutes to fill out the rest of the table in your materials and answer Alex's question. Pause the video to complete this work. Perhaps you found that Alex will have earned enough money to buy the $220 gaming system by the end of the summer. Does your table look like this? I was able to multiply each of the number of weeks by 28 to find the corresponding total earnings. Think about question B. Are Alex's total earnings proportional to the number of weeks he worked? How do you know? Pause the video while you answer this question in your materials and press play when your answer is complete. You might have been thinking, yes, the table shows an example of a proportional relationship. Alex's total earnings are proportional to the number of weeks he worked. We can multiply the number of weeks he worked by a constant value of 28, which determines the corresponding earnings for that week. Today we worked on answering the question, is this a proportional relationship? In thinking about our work, we knew there was a proportional relationship if there was one constant number that could be multiplied by each measure in the first quantity to give the corresponding measure in the second quantity. To continue your learning, please complete number 2 located in the problem set for this lesson. Thanks for all of your hard work today. See you soon.